After education within the thymus, T cells circulate throughout the lymphatic system and accumulate inside the lymph nodes, spleen, and other secondary lymphoid tissues. Other types of cells are also present, including B cells and macrophages, both of which can also act as antigen-presenting cells. Consider a macrophage. Should it encounter an antigen for which it has no specific receptors, it can still engulf it using, for example, its lectin-like receptors. This is termed non-specific internalization. The pathogen bearing the antigen is contained within a phagolysosome in the macrophage. Other vesicles fuse with the phagosome, bringing proteolytic enzymes in. Elsewhere in the macrophage, major histocompatibility complex molecules are being synthesized at the endoplasmic reticulum. MHC class II molecules are transported by the vesicles, which intersect the pathways of vesicles released from the phagolysosome. Proteolytic fragments of the antigen bind to the MHC class II molecules in a special compartment, displacing the invariant chain of the class II molecule. Loading is facilitated by another MHC-encoded molecule, called DM. The vesicle containing the MHC class II antigen fragment combination migrates to the surface of the macrophage, where the contents remain attached, presented to any Th1 cells that may be encountered. A Th1 cell that recognizes the particular antigen will bind to the surface group of the macrophage using its T cell receptor plus a CD4 molecule which recognizes the MHC class II part of the presented antigen fragment. This binding alone is insufficient to trigger T cell activation. Other co-stimulatory molecules already on the surface of the T cell come into play. ICAM1, which stands for intracellular adhesion molecule 1, on the macrophage, binds to LFA1, lymphocyte functional antigen 1, on the T cell, while CD2, also on the T cell, binds to LFA3 on the macrophage. Meanwhile, an interaction between CD80 on the macrophage and CD28 on the T cell delivers a powerful co-stimulatory signal to the T cell. The macrophage releases cytokines, including interleukin-1, and the T cell makes interferon gamma. In this way, each cell activates the other. The macrophage is put into a more hostile state to destroy any bacteria it has taken up. The T cells released interferon gamma will activate other, as yet uninvolved macrophages and other cytokines, such as